Then in 1992, Breyers and his colleague they came up with the idea. Let's think there is more than one data, okay, and you have to timestamp them. So they came up with the idea. Let's with blockchain. Let's start using Merkle tree also. So they give idea to use Merkle tree inside the blockchain. So we'll look into that in future slide how that are implemented in blockchain. Then ultimately in 2008, Satoshi Nakamoto he came up with the idea like okay, whatever in 1999, 1991 and 1992 they thought that particular time, let's implement that in real world. Okay, Satoshi Nakamoto came up with the idea of a cryptocurrency. He used the blockchain concept. Now, who is Satoshi Nakamoto? It's not still revealed that who is Satoshi Nakamoto. It may be a person, it may be a group, or it may be he may be still alive or maybe dead. No one knows. So now but still in paper published in 2008, but it took few years to implement. In 2014, the first implementation of blockchain was done, and after that it became really famous. You know about Bitcoin, how it's go up and down. These all things are there. It's crazy market. Like in 2017, end of the December, it reached $19,000. Now again it's back to $8,000. Started from $1, less than $1, and now a huge price. That much famous it became. So now these are the prerequisite you need to understand before blockchain. Now uh, these topics I'm not going to cover here. If you want to, these are the very basics topic. If you want to learn about this topic, I will be referring you to another PPTs, or maybe I will be creating one more PPT on that prerequisite I will be sharing with you. So these are the main thing. These are the four pillar of cryptocurrencies or blockchain, like cryptography, hash function, data detailing or data manipulation or peer-to-peer network. Now, what is blockchain? So you can see the traditional um, information like a digital ledger in which transaction made in Bitcoin or other cryptocurrency are recorded chronologically and publicly. Now, this was a very small example of blockchain. Blockchain are not bind to this area anymore. They are not bind to cryptocurrency anymore. Blockchain reach several other platforms also, like smart contract, medical, finance, transport, marketing. These all area blockchain are now used. So, if you go to a very layman term, what is blockchain? In blockchain, it is nothing but some blocks are there. They have contain some information, and this all blocks are linked with each other. So you can refer the below image. There is several blocks are there. Somehow they are linked to each other. So in future we are going to look into that. This block contain which all information and how they are linked with each other. The first, a blockchain block contain data. Now, if you look into cryptocurrency, the data is the transaction information. Like if I transferring one Bitcoin to you, that information will be stored as a data. Now, in other section, the medical information, like if it is a hospital, they want to create a medical information on blockchain. So it will be like there will be a patient, his medical history with timestamp. Maybe today he came for a doctor checkup and doctor suggests for one um, maybe a X-ray. So that information will be stored as a timestamp. Now, second, it will be again maybe after a few days he came for one more visit. Doctor can go back and check, okay, in previously he came for some treatment there, that time doctor suggested some X-ray. Now they can refer the previous and keep the data in new block also. So on that way, the data will be linked with each other, and in future we'll look into that how that will be helpful. Now second thing is the timestamp. Now we know that blockchain contain timestamp. Every data is stored with a timestamp. So whenever we are transferring one Bitcoin to another, so what happening? The transaction information are stored with the timestamp. So you can refer the image here, like if a person A is transferring Bitcoin to person B at this particular time, the data will be stored with the timestamp. We'll look into that what is the importance of timestamp. Now third is, what you're going to do is you're going to create a hash value of the data and timestamp together. So now you have data plus timestamp, and together you are calculating a hash. Now if you know about the hash function, there is maybe your data is something. If you make any changes on the data and you calculate the hash, and then if you match that hash with the actual data hash, it is not going to match. Even a single changes made into the data, the hash value will be changed. Like if you have your name written in a capital letter, you calculate the hash, then you write your name in a small letter and calculate the hash. Though the name is same letters are there, but the letter, the capital and the small are these difference are there. So hash value will be changed. So if maybe I have a data, now I want to pass it to you. Now the data is very important. Maybe a company information I want to share with you. Now there is a chance some man in the middle attack can happen, and they may able to tamper the data. Now what you can do is you can calculate the hash of the data, you can share the data separately and hash separately. Now if the person able to manipulate the data, you are going to verify the hash. The hash, if the hash don't match, then you can identify, okay, someone manipulated the data. So what you are doing? First, you are creating your data, you are calculating the hash. Now you are sharing these two with me separately. Second thing is, if there is an attacker in between, he got the data. Now he is going to manipulate the data and then he is going to share with me. So what I'm going to do is, I have your hash. Now I have the data. I'm going to calculate the hash of the data. Now I will going to get a hash. I'm going to verify the hash with your hash. If both hash is match, then data is not tampered. If hash don't match, then the data got tampered. Now what is benefit of a timestamp? Now if you add a timestamp with the second also, so even 1 second pass, the timestamp will be automatically captured from your system. Now if you are creating this data at the time like 2 a.m. and 10 second, and the data you are going to share um, through the network, and if there is an attacker, he need to change the data, then he have to follow the same timestamp. Now that is difficult. Now you know the timestamp, but attacker don't know the timestamp, what time you created the data. Okay, even he know the data, he is not able to manipulate it because it is bind with timestamp also. Now that is not going to. We are not actually encrypting the data. We're actually following a timestamp only and hash only. Now fourth thing we are going to discuss after point 5, because that is more important here. Now the point 5 is, what you are going to do, you are going to create a hash value of together of 1 2 3 4. Now this all value you're going to take together and going to create a hash that is going to give you a block hash. Now same like now previously, and if you remember about point 3 there, if the data is manipulated, the hash will be changed. So here data, timestamp, even your hash value, if you someone manipulate the hash value, or the point 4, anything, they manipulate the value of the fifth point is going to change. So attacker need to change one value, then the fifth is going to change. So if any of the four is manipulated, the fifth is going to change. Okay, now look at on the fifth point. Now fifth point is the previous block hash, like same hash of current block like fifth, the same value will be passed to the next block. Now your this block have contained information of 5, like all 4 came together and created the hash. Now this hash is going to pass to the next block. Okay, and that will be stored in the fourth position. Now what is the important of that? Now you have two block. Okay, now if anything changes in the second block, maybe think that attacker is targeting your second block. If you change anything in second block, you're going to catch from point 5. Okay, now attacker change maybe the previous block. How you are going to get catch him? Now previous block, if he change anything, the hash is going to change. Okay, now you have the previous block hash in point 4. Okay, you're going to match the hash with the previous block. If that is not going to match, that means attackers manipulated your previous block, so this block is not valid anymore. So this way you can secure. So now look, this all point together. So think that there is 3 blocks are there. Okay, now 3 blocks, there will be information. Here I am taking as an example as a transaction information are there in all 3 blocks. Now this all 3 blocks are linked together. How they are linked together? If you able to check, like first block, there is a previous block hash is there is zeros because there is no previous block are there. This is called genesis block. Okay, now there is a current hash, current block hash. This is all data 1 2 3 4 point came together and created the hash. Now this current block hash is passed to the next block. Like check in point block 2, the previous block hash is same like the first block hash, because this hash information is passed to the next one. Now same way, second block has the current block hash, and that is passed to the third block. So this way they are linked with each other. So any block got changed, the full blockchain will be invalid. Okay, clear? Let's move to next. Now think that one block contain more than one information, like more than one transaction details are stored there, or maybe more than one client information are stored there inside one particular block. So how you are going to calculate the hash? Now all point will be the same. Instead of point 3, that it will be not the particular data hash with timestamp, it will be the TX root. Now what is TX root? Now we remember that in 1992 there was Merkle tree implemented in blockchain. So let's check how that is implemented. The TX root nothing but the Merkle tree implementation here. Now think there is a 4 data are there. Okay, in particular hash, particular block. Now this 4 data, every data have their own hash. Okay, now what you are going to do? We are going to do a Merkle tree calculation, like 2 block hashes will come together, combine their hash and going to form a new hash. Okay, so like HA and HB came together. HA here refer as a block, a transaction A or data A hash, and HB here data B hash. When data A is there and data B is there, and you calculate the hash of both of them, and what you're going to do, you're going to put these two as a data, these two hash as a data, and going to calculate the hash again. So maybe you got a hash, this as a hash, HA as a hash in data A, and HB has as a data B. So now HA and HB is your data, and you are going to calculate the hash of HA and HB, and that is going to give you a hash. Same way here CD will be done, and they will become again together. When HAB and HCD come together and create a hash, that will be the TX root. So more the data, more hash will be calculated and combined together and going to create a TX root. And then the TX root will be stored inside the block. So till now we covered the components till components. Now in next video we will move into the second part of the blockchain.